Hi everyone, Professor Bob Young here with some more on absolute value equations. Now, did y'all know that there's only one thing more fun than just one absolute value in an equation when you're solving, and that is when you have more than one. So the rule is here, we're going to go ahead and entitle this one double absolute value equations. The rule goes something like this. All right, so let's go ahead and say, and we'll do this in pretty green here, if the absolute value of x equals the absolute value of y, we'll make a little if-then statement, then x equals y, or x equals the opposite of what's in that second absolute value, which we're calling y. All right, so it's kind of similar to when you have a single absolute value equal to a number. You say, well, it's equal to the number or its opposite. Well, this kind of works the same way. You just take what's in the first, set it equal to what's in the second, solve, and then you take what's in the first and set it equal to the opposite of what's in the second and solve. So we're going to do a few examples with this right now. And I'm going to go to different colors here. So let's say for our first example on this, we have the absolute value of 3 plus 6x equals the absolute value of 4x plus 11. All right, so to get the two answers, or you may have one answer, or you may have no solution on these again, take what's in the first one using that rule we already discussed. 3 plus 6x equals the second one. Or to get the second answer, take the first one and set it equal. Now here's where students get in trouble on this one. They don't show their steps. You must set it equal to the opposite of the second one. All right, so solving here, we're going to subtract 4x from both sides here. So I'm going to go left with the letters, and then I'm going to subtract 3 from both sides and go right with the numbers. So that's going to give me 2x equals 8. Dividing by 2, here's my first answer, x equals 4. For the second answer, I'm going to take that 3 plus 6x and set it equal to the opposite of that second one there, or distribute this minus sign here through, which will give us minus 4x minus 11. So we can add 4x to both sides. So again, I'll go left with the letters, subtracting 3, I'll go right with the numbers, and that will give me a total of 10x equals negative 14, and dividing both sides by 10, the second answer will be x equals, reducing that fraction, negative 7/5. And once again, both of these answers should check if you did it right. So in other words, if I take 4 and I plug it back in here for the original problem, I should get something that makes sense. In addition, if I take negative 7/5 and substitute it back in, it will work as well. So let's just take 4, since I want to do one more of these just to make sure y'all have it. And we'll plug 4 in here. So we'll say, is 3 plus 6 times 4, and remember we're taking the absolute value of that, equal to 4 times 4 plus 11, taking the absolute value of that with the bars. So the first absolute value, and I'll sneak it in here, we're going to get the absolute value of 3 plus 6 times 4 is the absolute value of 27, equals the second one, the absolute value of 4 times 4 is 16, plus 11 is the absolute value of 27. It does check. And I bet you $100 the other one will check as well. All right, let's try one more example on these just to make sure you have it. So I'm doing these quick hitter videos for you. And I'm going to do one now where you only get one answer on a double absolute value. And I know what you're saying, Young, how can it be? How can it be? Well, I'm going to show you here. So let's take the absolute value of 4n plus 5, and I'll change the variables around just so we don't get bored with x and y all the time, is equal to the absolute value of 4n plus 3. So again, on a double absolute value equation, take the first, what's inside the first absolute value, set it equal to the second. Or to get the second answer, take what's inside the first and set it to the opposite of what's in there. So all the signs are going to change in that second parentheses there. So be careful. All right, now look what happens in this first example here. When we solve this first equation, when we subtract 4n from both sides of the equations, the n's go out, leaving me with a false statement. So in this case, when the variables go out and you have a false statement, this is called a contradiction, it has no solution. No, there's no answer to this? Are you telling me that? Now hang on, we haven't done the other one yet. 4n plus 5 distributing the minus through gives us the opposite of all the signs in that second one, so it'll be minus 4n minus 3. Now notice what happens here. When I move the letters to the left, I will get some letters. I'll get 8n over there. Then I'll subtract 5 from the other side, so what I end up with, letters left, numbers right, when you solve linear equations, 8n equals negative 8. Divide by 8, n will be negative 1. So in this case, you only had one answer for the double absolute value equations. And as always, remember, if you go to course documents, I try to give you these helpful handouts here. So let me go ahead and pull that up that I talked about in the first one here. And notice down here on the bottom, there is that rule I discussed. So we'll look at it, double absolute value equations in graph, and I'll underline it in red here. And I gave you yet another example. This one down here has two answers. So the absolute value of x equals the absolute value of y. Just remember a little trick and practice enough to make it stick. All right, Professor Bob Young signing off. Have a great one.